Okay, hi everyone. I'm Andy Cobley. I'm from the University of Dundee, and the first thing I'm going to do is take a picture of you lot just to prove I was here. Done. Okay, so what am I going to talk about? I'm going to talk about Cassandra on a Raspberry Pi, and I need a clicker, which is this one, I think. So basically, Cassandra's hardware agnostic. It runs on just about anything that will run Java. So my question was about 12 months ago, why not run it on a Raspberry Pi? How hard can it be, you know? And once we've done it, what can we do with it? So I'm Andy Cobley. I'm from the School of Computing, University of Dundee. That's in Scotland. I don't sound Scottish. That's because I'm from Liverpool. So what is a Raspberry Pi? Anyone own one? Yeah, a couple of you? It's a few. It's really interesting. When I first started out this talk, there would be like no hands, and about 3 months later, everybody had one. And over here, there's like a few of you, so that's quite good. Essentially, it's a single-chip Linux computer, 256, 500 meg of RAM, really tiny. Boots off an SD card, no hard disk, which makes things interesting. It's got an Ethernet port, and it's got everything you need, basically, to run it as a general-purpose computer. That's one with a pound coin. You might not know what a pound coin is, so I've got one here. Anyone wants to have a try? It's the first time someone's thrown a computer into the audience here, I suspect. And there'll be more magic tricks. So what I did is I came over from the UK and I brought a Cassandra cluster with me. There is a 4-core Cassandra cluster being held up in one hand. Okay, I was actually going to show that on the video, but this is a bit better. If anyone wants to see it running, we can plug in a laptop and you can see it running later on if you want. Okay, so we all know that Cassandra is good at reading and writing. It's very fast, extremely fast. Laptop I've got here will do about 12,000 write operations. Raspberry Pi will do about 200. Okay, so you're not going to run this in production environments, let me tell you. Okay. Actually, if you try running it with an external USB drive, it's actually worse. This is all down to the hardware. Basically, to keep the cost down, they shared the bus between Ethernet, USB, and this. That's going to slow things down. It's not terribly fast anyway, because it's about the same speed as a 2001, 2002 PC. Skip that one. Then there's the problem of Java. You know, people say don't use OpenJDK. That's one reason why. Certainly on a Raspberry Pi, that blue line is OpenJDK. The top line is Oracle JDK. You're not going to get much speed. Then there's the problem of there's two different variations of operating system on Pi. There's Raspbian and Debian. Raspbian is accelerated for the floating point accelerator. The Oracle JDK wouldn't run on that until quite recently. Fortunately, they released a beta version just before Christmas that I've been running. You can get a preview version from it now. Doesn't actually make much difference to the performance. This was a real pain. I was looking forward so much. We were actually prodding Oracle, come on, get a release for Raspberry Pi. And then it didn't actually make any difference. Well, no real difference. Then there's the problem of compression. As Ellis was saying earlier on today, there's a compression before writing to disk, and that's you've got a choice of compression. That gives a reduction in data size. It also gives performance increase on reads, performance increase on writes as well. You may remember Cassandra used to be said Cassandra is very fast for writing, very slow for reading. They introduced compression, and that sort of brought those two into the same sort of level. Two types of compression: Google Snappy compression and a deflate compressor. Version 2 of Cassandra, they're bringing in a new different compression entirely. Problem is that Snappy compression doesn't run on Pi. It requires native methods. This actually stopped Cassandra running on Pi for quite some time because in I think version 1, they put Snappy compression on by default. Snappy compressor actually didn't return an exception, and it just returned an error, and Cassandra blew up in your face. We had to fix that. Then there's the startup script. You probably don't know this. You guys are all running sensible machines. The startup script calculates how much memory, based on the number of processors. Raspberry Pi returned 0 processors. You got 500 meg of memory, you divide that by 0, bang. That's been fixed. In the Cassandra.env.sh, you'll find a nice line like that. If you don't have that turned on, your nodes aren't going to talk to each other. Okay, your node tool won't work properly. And then in 1.2, they added the use cond card mark as a JVM opt. Guess what? Doesn't work under Oracle JDK 8. We have to get rid of that. If you are trying to do this under JDK 8, then you'll have to go into that shell script and comment those lines out. Why don't I just give up? There's lots of problems here. Why bother doing it? One thing we forgot, that thing you're passing around costs £25, that's about $30. You can power 4 of them from one USB hub. This is how I'm powering this. I've just got that one USB hub powering all 4 of them. Okay. Actually, I was really worried when I came here. I thought that your 110 volts wasn't going to work. I brought a network hub with me, and that didn't work on 110 volts. I had to go running around looking for a network hub that would run on your voltage. Anyway, so we got £25. Why not have a 64-node computer for £2,000? About $3,000. That's University of Southampton. They built that using Lego, by the way. That's Lego holding that lot together. There's a guy in Boys University. He's got a 32-node Beowulf cluster that he's using for his PhD research. That's nice and cheap. As you know, adding nodes is good. Raspberry Pi really doesn't like being unbalanced. You know this problem when you don't get your keys in the right place in the conf file, YAML, it gets unbalanced. Raspberry Pi really doesn't like that. You've only got 256 megs of memory, maybe 512 megs of memory. What happens is you get a really hot spot, and then it just blows up. It dies on you. So you're going to need to make sure your ring is pied. It's balanced. It'd be very nice if we could use 1.2. At this point, I've not got 1.2 running on a cluster. You can run 1.2 on a Raspberry Pi fine. Running on a cluster, they don't like talking to each other. I've yet to get to the bottom of that. It might be that JMX error I was talking about earlier, but we'll have to have a look. So you can't use vNodes. This is a graph I like to show people. This is performance on a 3.4 node Raspberry Pi. You can see we're maybe getting 700 operations per second for writing. You can see you get a speed increase. This is using the stress test command. I'm going to ask anyone in the audience. Maybe you know. You see at the end, you see the green line and the blue line. At the end of the stress test, that performance drops like a stone. Anyone any ideas? I'm actually asking this because I don't know. I'll go and meet an expert and I'll ask them. Okay, this is an older version of Cassandra, and you can see that the write speed, the red line and the blue line at the bottom, quite considerably less than the read speed there. That's the 456 node insert. I'm still getting that drop off at the end, but you can see that we're getting a reasonable speed increase as we add nodes on the Raspberry Pi. I've had it up to about 8 nodes, and I think you get a distinct, it just stops getting any more performance. The performance doesn't improve once you get above 8 nodes. I think that's because it's becoming network bound. You know, I was saying earlier that the hardware was shared between the SD card and the USB and the network. I think it just won't go any faster than that. Okay. So you can get 8 nodes running. You have to be careful when you're doing this because, say, Snappy Compressor doesn't exist. You have to use the deflate compressor to be able to get this to work. You'll probably have to do that if you're going to do any programming on them as well. Note that I'm injecting directly into multiple nodes there. The more nodes you insert into, the faster you're going to get it running, of course. Because we haven't got 1.2, we've got this unusual problem. Now, I guess a lot of you guys are using things like Op Center and Puppet, etc., for adding nodes, yeah? That sort of thing. Can't really do that on Raspberry Pi. Op Center doesn't want to run. I think that's something to do with OpenSSL not being entirely supported on the Raspberry Pi. So you need to go through all the pain of adding the correct keys, making sure it's balanced. Don't let it try and balance itself. You're going to end up with it blowing up on you. It doesn't matter, of course. I give this talk quite a lot to people who are interested in Raspberry Pis and aren't interested in Cassandra. So I include this just for them, really. This is a bit of Python code that will allow me to calculate the keys that we need. And of course, you need to use node tool to move your stuff around. If you're doing this by hand on a 4-node, it's quite easy. If you're doing it on 8 nodes, it starts to get to be a pain. One thing you can do on Debian or on Raspbian is you can get more memory. By default, the Raspberry Pi allocates about 64 meg, I think, to the graphics device. You don't need graphics if you're running Cassandra and you're SSHing into it. You just need to be able to get as much memory as you want. On the old version on Debian, you can just do that by going into the boot sector and you copy the ELF files like that, which gives you more space. Under Raspbian, what you need to do is the first time you power it up, it powers up into this question and answer session, which allows you to set up how much memory you're going to use, and you want the minimum amount of memory to the graphics as you possibly can. I always use static network addresses. This is just for anyone who's never actually done this before. For those of you guys who are used to using Windows, perhaps, you just need to go into etc. network interfaces and add those set of lines. This is just for reference if you want to do this at home yourself. One of the nice things you can do with the Raspberry Pi, let's turn one of these off. Because this is all on a SD card, you can basically make a master image, copy the contents off the SD card onto your hard disk, and then make as many copies as you like. So I work in University of Dundee. One of the things we're wanting to do with these is to use them for teaching people about how to set up Cassandra clusters. So we can set up multiple environments on different SD cards, hand them around to the students, they can copy themselves, they can go and get 4 nodes for 100 quid if they want to, and play with it at home with different configurations. If you're not using the DataStax Community Edition, you want to be able to run this starting up on PowerUp. I've got a wee GitHub site there with a Cassandra startup script. Will not bother showing you, but if you want to, you can download that and you can use that, put it into etc. initd, and use update rc-d to get it to run on PowerUp. So, in conclusion, I kind of ran through that quick because everyone else has been told to hurry up. 200 quid, we can get an 8-node Cassandra cluster. We can reconfigure it, we can blow it away, we can stress test it, and we really don't care what happens to it. In an educational environment, which is what these are made for, you can hand these out. If some kid decides they want to steal one, buy another one for 25 quid. You're not replacing vast quantities of machinery. If someone decides they want to overwrite the SD card with something else, That's okay, you just copy it back on again. No problems. We can simulate data racks, data centers. Hopefully we can do long network delays.
Why does it say that? Oh, but does the TC work on Debian?
I've never tried it. So I was going to show on my next slide, hopefully. Maybe then one of them. We know there can be data. This is what I'm trying to do, okay? So I've never done it. Basically, I'm thinking you get a switch with 3 pies on either side, put a hub in the middle, not a switch, a hub, inject a bunch of noise, and you can make that link as slow as possible. So you were saying there's what?
TC?
TC?
It's a Linux tool for simulating delays in packet loss.
Okay, never tried it. I've never tried it. It might do.
If you have a specific node, you can tell it to add 500 milliseconds. So we usually do it to simulate a Cassandra slow node.
Mm-hmm. On big machines?
Yeah, on normal Linux machines.
Okay.
But if Debian supports TC.
It might do. That'll be the next thing I'll look at. That's good. If not, I'll go back to hardware. Anyway, that's fun. So, when I first started out, Cassandra wouldn't run on Pi. So one of the nice things that this little exercise has done is that it's allowed me to put stuff into the code base. That means it now does run on Pi, so everyone else can feel my pain. It shook out some Cassandra bugs, which is interesting. One of the interesting things that we have an MSc, and we've got people who work in secure labs. In other words, they're not allowed to bring machines in. They're not allowed to just run any bit of software or any bit of hardware without taking 6 months before they can actually, it has to be sort of go through quick QA. He sits in the canteen with his Raspberry Pis and tests various software architectures. So, for instance, using Storm, using Hadoop, using something else. And then he can go and request this software and have the 6 months pain. So you can play with configurations without having to make a huge expenditure. Most importantly, when I set out to do this just for fun. And that's what it really is all about. Pure geeky fun. It's the same sort of thing that makes people play with Arduinos, to make people drive robots. Can I make Cassandra run on this? Yes, you can. I wouldn't have got here from Scotland if I didn't have that slide. So basically, we're running a data science MSc at the University of Dundee. So if anyone's interested in that, ask me about it later. So it's cheap, needs some work to run on. You can make clusters very cheaply for experimentation. There's an example. One of our data science students wanted to test high cardinality bitmaps on Cassandra. He fired up a 4-node Amazon cluster, ran his tests on it. That cost him about $40 to run those tests because he wanted a good cluster. Came to me, gave me the results, and I said, so was that with vNodes or with not vNodes? And he said, I don't know. I'll have to go back and fire up this cluster again, do all the work again, charge another $40 or whatever it was. So if we want to, we can give them these toys to play with without lots of expenditure. Okay, thank you. That's all I needed, some questions. Any questions?
I guess, how long have you run one of these clusters kind of continuously for? I'm kind of thinking in terms of, can these Raspberry Pis run for, 10,000 hours, right?
Oh, I don't know about 10,000 hours. So I set up this one. This is 1.1.1. I set it up in March, I think, in my spare room. Forgot about it, and when I came here, it was still running fine. So, I mean, it wasn't being loaded, it wasn't being stressed, but it was running. And you could still plug in and do everything you're meant to do. So it seems to run quite happily. I have to say 0.8 and 0.9 weren't quite so resilient. They fell over after about 5 days. Yep.
What was the replication factor?
Sorry?
What was the replication factor?
For those stress tests, that was just one. Yeah, it wasn't replicating many. But that's the sort of thing you can do. You can say, well, you know, what happens if I do start replicating, and you know, that's the point.
I have a question. Have you tried using an Arduino or maybe an MSP430 launchpad instead of the Raspberry Pi to see if you get different results?
No, but what size Arduino are you talking about? Because
We
a standard Arduino will not run Cassandra.
No.
No. Standard Arduino's memory is tiny, and I used one a while ago for other things. I was using it to contact YQL for displaying tweets on an LCD display. And I was trying to store the top 10 tweets I was getting, and I was running out of memory just trying to do that. Because what happens is its stack comes down, and the memory goes up, and they just overwrite each other and bang quite quickly. Someone at the back?
Yeah, my question was kind of a similar vein, alternative. Now that you played with this a little bit, I think you can see probably different possible hardware configuration might be better. Something that didn't share the bus or didn't have a video card.
Yeah.
Or are you looking for any alternatives to Raspberry Pi?
At the moment, I'm not, you know. But yeah, there are. I don't know if it was this that started it, but you're right. There are new single board machines of this sort of size and this sort of price coming out by the minute. I'm told these guys, they've sold 1 million of these now. So there's a certain momentum.
Optimize one for a node, something that had a really good network.
Yeah, that would be. That would be.
You might get to the bottom of what's causing them to
Yeah. Yeah. This is just one example. As we say in this country, other devices are also available.
Thinking about the uses of using Raspberry Pi in different scenarios, right? How robust is the device? For example, I have a customer who, let's say, shipping companies, they want to track things and they want to actually be able to make some decisions right there without a network, or being able to transmit data over the network. How does this device handle?
They're pretty. There's no moving parts. These cases that I've got this in, they cost about $5 or something. They're pretty strong. You know, I mean, obviously, if you broke the PCB, then that's going to break it. But everything else, they're fairly robust. They are essentially, and when it comes down to it, these are a mobile phone without the phone bit and without the screen. That's all they are. Okay, thank you very much. It's been a wonderful audience.